Alright, today we have the basic circuit theory and we need to solve the voltage and the charge or the current on each component of the circuit. Let's start. So the first circuit is the circuit which contains capacitors, and in the series the capacitors are solved like 1 by C1 plus 1 by C2 and so on, and in the parallel the capacitors are solved directly, so that would be C1 plus C2 and whatever it is. Okay, let's start now. With the basic concept, we can see that 6 and 3 they are in series. So you can also adopt one formula for series, like that would be C1 C2 divided by C1 plus C2. So that's simply like multiply divided by addition. Okay. So if we solve this circuit and we try to reconstruct the circuit again and again, we have to find the equivalent capacitance first. So let's start. That would be like 6 and 3. We can have a rough calculation. That would be 6 multiplied by 3 and 6 plus 3. So that would be 18 divided by 9. So that's 2. So we can construct a circuit again in which we have a circuit in which we have the circuit components as this will be 2 microfarad, and this is already 2 microfarad, and then we have a connection with the 4 microfarad here, and there is a 10-volt battery. Now if you solve this 2 and 2, they are in parallel, so that would be 4 microfarad. And then what we can do is we can add them directly. So that would be like 4 microfarad, and again it's like 4 here with the 10 volts battery. Now let's get to the circuit. If we solve the 4 and 4, they become in series. So that would be simply 4 multiplied by 4, and 4 plus 4, that would be uh, 2 microfarad. That will be the overall capacitance. Now we have a circuit. If you simplify the circuit further, so you have a circuit with 10 volts battery and 2 microfarad capacitor. Okay, now let's try to find the charges on each of them and the voltages on each of them. So if this is a circuit, the charge flowing through the circuit, that will be Q is equal to CV, and I can simply write that that would be 2 multiplied by 10, and that would become 20 microcoulombs. So that means a charge of 20 microcoulomb leaves from here and reaches back the battery. Fine. So let's go to the circuit, the previous circuit. That would be like charge will be moving from here, going from here, and then again it will be coming back to the battery. Now this is the isolated capacitor. Like what I mean to say, like this is only the single capacitor in the circuit. So this can be solved quickly. On this case, the charge passing through this capacitance will be 20 microcoulomb, and you can use this formula again and again to find the voltages and the other stuff, like whatever it is asked. So if you have 20 microcoulomb charge passing from this 4 microfarad capacitor, you can divide 20 by the capacitor, like the 4, to get the voltage. So that would be 20 by 4, that is 5 volts. So the first portion is solved. Let's go for the other portion. And similarly, this is the similar capacitor. So that would, the 20 microcoulomb will pass from here with a 5 volts battery, like the 5 voltage, the voltage of 5 volts. Now let's get back to the previous step here. Now what we have, the charge coming from here, that was 20 microcoulomb, which has to divide in both of them, and it will leave from here as 20 microcoulombs. Fine. So now in this case, although they are equal, the 2 microfarad and 2 microfarad in the parallel, they are equal, so the charge will be divided equally, that's for sure. But let's get into the proper method. The 2 and 2 added up to make 4 microfarad. Okay, and obviously they are in parallel, so we pick the voltage because voltage is same in parallel, so that would be 5 volt. And if you pick this also, this would also have 5 volts. Fine. Now what will be the charge flowing in each of them? So the capacitance is 2, the charge will be 5 into 2, that will be 10 microcoulomb, and that would be 10 microcoulomb, this formula. Then if you go to the circuit previous one here, because this is solved, this is solved, now the only circuit left is 6 and 3. We need to get the 6 and 3 answers as well. So the charge passing through 6 and 3, that is 10 microcoulombs. Okay, because this 2 microfarad was the equivalent of 6 and 3. Fine. Now this is 6 microfarad and this is 3 microfarad. So the last step concludes that the charge passing from both of them will be equal because they are in series. And what will be the voltages? So the, if you solve this circuit, that would be 10 microcoulomb charge, and if you divide 10 by 6, that is the voltage here. For this also the charge is 10 microcoulombs. Series circuit, the charge has to be same, and the voltage on this will be 10 divided by 3. So this is the circuit. That's the first circuit we have solved. So now you can mark on the capacitors like what is the voltage and the current charge on this. So if you just pick this 4, it has a charge passing like 20 microcoulombs. That's like including the circuit now, 20 microcoulombs, and the voltage on this is 5 volts. If you pick the 2 microfarad, that's like the voltage is 5 volts here, and the charge passing is 10 microcoulombs. If you pick the 6, then it would have a voltage of uh, 10 by 6 volts, and the charge is 10 microcoulomb. If you pick this one, it would be 10 by 3 volts, and the charge passing here is again 10 microcoulombs. So now that's the circuit. We're done. Okay, let's head towards the next one. It could be a bit lengthy. Alright, now see, we have a lot of parallel combinations and we have a lot of series combinations. Obviously, all of them will join them in series only. So let's try to figure out the equivalent capacitance first. That would be, let's start from here. The 4 and 4 will add up to give a voltage, sorry, the capacitance of 2 microfarad, and then 2 and 4 are in series. So if you want to draw the circuits again and again, that would be a little bit lengthy. So let's try to solve this in the first step. So this 4 and 4 will be 2 microfarad, and then we have the 4 in parallel here. Okay, and 1 and 1 we can solve equivalent as 2 microfarad because they will add up in parallel. Then we have a battery here of 18 volts. We have 6 and 3 and then 2. Okay, so 6 and 3 are in series, so you can solve this. We have done this earlier as well, so that would be 2. So we have a circuit with 2 here and 2 here, and let's 4 microfarad here, and this is 2. So that's a little bit equivalent of the circuit. Like we tried to solve it to make it a little bit simple. And let's now try to solve the circuit further. So this is 2 microfarad, this is 2 microfarad. Fine. If you just simplify it further, the circuit should look like this: 3, 6, 3, then it's 2 microfarad here, then it's 18 volts, and then 2 and 2 is 4, and then we have one more circuit, one more capacitance in the circuit, that is 4. Okay, so this is 4 microfarad, this is 4 microfarad, this is 2 microfarad. Now let's try to solve this further. Now see, 3 and 6, obviously I have told you that they will make a combination of 2. Now you can also add this 4 and 4 in series, so that will also give you 2 microfarad as the equivalent capacitance. Now for the last part of the circuit, now let's simplify it to the last. Uh, the last portion of the circuit will be, this is 2, this is 2, and this one is 2 here. So we are on the verge of the last step here, and that's 18 volts. Okay, so three capacitors of 2 microfarad in series will make 2 by 3 microfarad as equivalent, and if you find the charge Q in the circuit, that would be C equivalent multiplied by V, so that is 2 by 3 microfarad multiplied by 18, so that would give you 12 microcoulomb charge flows from the battery and to the various parts. Now the circuits have to be drawn carefully, one by one. So from this step, we'll try to go backwards. Let's check the step first. This is 18 here, and then we have 2, then we have 2 here, and 1, 2 here. So the charge flowing through the battery was 12 microcoulombs, which will pass through all these three capacitors. Okay, that would pass in a series circuit like this. So whatever it is easy, we can solve it directly, and the things which will be complicated, we'll try to get over them slowly and slowly. Okay, so the charge will be 12 microcoulomb, which is passing through the 3 microfarad. Okay, so if you find the voltage on this, that would be 4 volt, because that will be 12 divided by 3, that's 4 volt. And we can solve this 4 here. The 12 microcoulomb will pass through this as well, and 12 divided by 3, that is 3 volts. Now how to check also this, see this thing, 4 volts and 3 volts, they add up to 7 volts. So 7 volt of the circuit is consumed, so the remaining is like 11 volts now. Okay, so in the end, when we find all the voltages, we should be aware that the answer of the total voltage should be 18. If it is less or more, then the circuit is like we have solved something wrong there. Let's try to get over this now. So in this capacitor, the charge is 12 microcoulombs, and the voltage will be 6 volts here. In this case, it would be 12 microcoulombs, and that would be 6 volts. And in this case, the same. This would be 12 microcoulomb and 6 volts. Now let's try to go one step back. What was the circuit? Let's see. Uh, the charge passed from here, then here. We just got the 2 microfarad as 6 volts each here. So this will be like having 6 volts in parallel. This has 6 volts. This will also have 6 volts. Okay. So uh, if we see this carefully, the okay, this is the voltage. So the charge passing on each of them would be CV. So that would be 6 microcoulombs on this and 6 microcoulombs on this. This portion is also solved. Now let's get towards this portion and the last portion, which is this one. These are the two remaining ones. Okay, now see this thing. When the charge passed, uh, let's come to this diagram first. The charge of 12 microcoulomb passed through this, through the 6 microfarad, which was the equivalent of this whole circuit. Okay, so this will have 12 microcoulomb as charge, and 12 divided by 6 will be the voltage. So this is 2 volts here. Okay, so this will be consuming 2 volts. Fine. Now let's go one step backwards. It was a combination of this three resistance, like 4 ohm, 4 ohm, sorry, 4 microfarad. Then we can get to this resistor quickly. The voltage on this will be 2 volts, and then if you want to find the charge, that would be 8 microcoulombs. Correct? Now it is pretty sure that the voltage on this will also be 2 volts, because 4 and 2 are in parallel. And the remaining charge, like if the charge was like 12 microcoulomb passing from here, the remaining charge will pass in the 2 microfarad. So that would be 2, oh sorry, that would be 4 microcoulombs. Again, 4 and 8 they add, and the 12 microcoulomb charge comes out. Now see, let's go for one more portion here. Now, when we know that the charge of 2 microfarad is passing here, so that means this capacitor is containing 2 microcoulombs, 2 micro, sorry, this, if the charge of 2 microcoulomb is passing from here, this contains 2 microcoulombs charge, and the voltage will be 2 volts on this, because that is Q by C. And similarly, it will be here also 2 microcoulomb charge and 2 volts. So this portion is solved, and this was having 2 volts and 8 microcoulomb charge over here. Sorry, the charge was 4 here. That's a bit of mistake here. The charge was 4 microcoulombs on this, so the voltage will be 1 volt, and this also has 4 microcoulomb, the voltage will be 1 volt. Okay, so this portion is solved now. Okay, now let's come to the other portion. Let's come to the other portion. Now this one is left. Okay, when we saw the circuit, the 12 microcoulomb charge has to come from here, and it has to enter the circuit. Now it's pretty sure that 12 microcoulomb when enters the 4 microfarad, which was the equivalent of 2 and 2 here. So what we'll do, so that would be 12 divided by 4, that would be 3 volts first. So that means there is 3 volts here and there is 3 volts here. Okay. So the charge flowing in this will be 6 microcoulombs, and in this also it will be 6 microcoulombs. Okay. I mean in this direction, sorry. Now it enters as 6 microcoulombs here and 6 microcoulombs here. So this is the last step now. You can find the voltage on this one. This would be 2 divided by, sorry, 6 divided by 2, this is 3 volts. And obviously in the upper circuit the charge has to be same. So this contains 6 microcoulomb charge, and that would be 6 divided by 6, that is 1 volt. Okay. And if you say on this one, it is 6 microcoulomb charge and the voltage is 2 volt. So I think we are done with all the components now. Yeah, we're done. Alright, now let's get to the next question. In this case, we have 3 capacitors of 6 microfarad in parallel. So if you add three of them in parallel, sorry, in series, so they would definitely give you an answer of 6 divided by 3, that is 2. So let's simplify the circuit directly here if it is done. This will be 2 and 2, which will give you an answer of 1 microfarad in series. Then 1, okay, let's make the circuit first. This is 1, and then you have 2 in the parallel. Then in another block you have a 4 microfarad, then you have 2 in the parallel. Okay, and the last steps are like we have a 4 over here and we have a 4 over here. This is 1, this is 2, this is 2, this is 4, this is 4 and 4, and this is 20 volts. Okay, so 4 and 2 will give you an answer of 6. Then you have 2 plus 1 here is 3, and then you have 4 here, and there is one 4 over here also. Now see, this is 4, this is 4, 20 volts. So let's find the equivalent here. The equivalent will be 3 and 6 will give you an answer of 2. 4 and 4 will also give you an answer of 2. 2 and 2 are in series. So C equivalent has to be 1 microfarad. And if you see the circuit of 1 microfarad, the voltage, like this would be the equivalent circuit. 1 microfarad. This is the equivalent last circuit. And then this will be 20 volts. Okay. So the charge flowing in this will be, this is farad. The charge flowing in this will be 20 microcoulomb. Fine. So that means a 20 microcoulomb charge leaves from here and it has to reach back the battery. Let us see which are the easy ones. So this one is directly solved. This is 20 microcoulombs charge and the voltage will be 20 divided by 4. That would be 5 volt. This could be easily done. The same 20 microcoulomb charge and this is 5 volts. Let's get to the other circuits now. Let's get to this one. Now, this circuit was an equivalent of 3 and the charge flowing was 20. So this is like 20 microcoulomb has to pass through this, and then you need to find the voltage on this 3. So that would be 20 by 3. This would be 20 by 3 volts. And then you take the other one, which is 6. That would also be okay. You can pass the 20 microcoulomb charge from here, and then it would be 20 divided by 6 volts here. Now this contains 20 divided by 6 volts, and this too also contains 20 divided by 6 volts. Okay. On the other hand, this too contains 20 divided by 3 volts, and this contains 20 divided by 3 volts. They are in parallel. Fine. So what is the charge flowing in each of them? Charge will be just multiplying the, that would be 40 divided by 3 microcoulomb, and on the above one it would be 20 divided by 3 microcoulomb. Now see, 20 by 3 microcoulomb charge enters here. This one is solved. This is like 20 by 3 volts comma microcoulomb, correct? Now in the above case, that would be 20 by 3 microcoulombs in both of them, and you have to just divide. So this will be 10 by 3 volts, and same, this has to be 20 by 3 microcoulombs, and the voltage is 10 by 3 volts. Let's come to the last circuit now. So this is having 20 divided by 6 volts, and you multiply by 4, that would be 80 divided by 6 microcoulombs here. And in the above case you have uh, that's 20 by 6. 20 by 6 volts. And what will be the charge here? Let's calculate this charge first. This would be multiplied by 2. So that would be 20 by 3. Yeah, that would be 20 by 3 microcoulomb. So the 20 by 3 microcoulomb passes through here, and in each of them it will be 20 by 3 microcoulombs. And if we need to find the voltage, so that would be like charge divided by capacitor. So that would be 20 divided by 18 on each of them, because they are similar capacitors and in series, so they will possess the equal charge and voltage. So this is done. Okay, now let's come to the circuit which contains resistors. So the concept is same. For the series circuit you have R1 plus R2, and for the parallel you know that that's 1 by R1 plus 1 by R2 and so on. So with this simple concept we have to redraw the circuits and try to solve them as quickly as possible. So this is the combination of 6 and 3, which is a very common combination in the circuits. That will give you an answer of 2 always in the resistors, not in the capacitor. So the equivalent circuit will be made as one resistor of 2 ohms. Then you have 4, 12 and 6. So for the three cases, like when you have three uh, resistors, then you can use this formula R1, R2, R3, or maybe I think the LCM is better. So that would be 1 by 4 plus 1 by 12 plus 1 by 6. Let's solve this quickly. The LCM should be 12. Let's take it as 12, and that would be 3 plus 1 plus 2. So R equivalent, that would be equal to 12 divided by 6. So that is 2 ohms. This circuit is also 2 ohms. And then you have the last one. This is also, I think 4 and 4 will be in parallel. So that will be 2 ohms. Okay. So that's it. Now let's get towards the currents. So 2 2 and will add to 6. So this is 12 is equal to I multiplied by 6. So I will be 2 amps. That is the current flowing in the circuit. 2 amps. Let's go further. Now the 2 ampere current flows here, 2 ampere is here, and 2 ampere is here. So let's calculate the voltage. This is 4 volts, 4 volts, and 4 volts. So they add up to 12. That is correct. Now if 2 ampere current goes from here, in the parallel the voltage is same. So this is having 4 volts, this is also having 4 volts, and if you divide them by 4 to calculate the current, that will be 1 ampere in this and 1 ampere in this, which is divided, like 2 ampere is divided to 1 and 1. Let's go to the circuit further. This is also having 4 volts and this is also having 4 volts, so you can calculate the current over here. This is 4 by 6 and this is 4 by 3, correct? Hmm. Okay, now the next one, which is this here. Um this was having 4 volts, so this means this is having 4 volts, this is also having 4 volts, and this is also having 4 volts here. Okay, because this is 4 and they are in parallel, so they have the same voltage. So this will be 4 divided by 4, 1 ampere here, then it will be 4 divided by 12, ampere, and simply this is 4 divided by 6 ampere. The circuit is complete. Fine. Let's go to the next circuit. Uh, okay. So in this case, 4 and 2, they will join to 6, and then you again have the 6 and the 3 combination here, which will give you an answer of 2. Then you have 10 and 40. This you need to solve. Okay, why I'm trying this again. This will be 20 volts, and this is like 6 ohms, and this is 3 ohms, and this will be 10 and 40 combination. So this will be 10 multiplied by 40 divided by 10 plus 40. So this will be 400 divided by 50. So this will give you 8 answer. I hope so. Yeah, that's 8. Correct. Mm, okay. So this is 8 ohms. Now let's go to the last part of the circuit. So 6 and 3 will give you 2, and this is 8. So it is better to solve the circuit and to transform it again and again, so that you can actually get to know how the branching can be reduced. And then again, from the reduction, we go back to the branching using the currents and the voltages. I mean, you have seen this in the video. So 8 and 2, they will add up to 10, and the current flowing through the circuit will be 2 ampere. Okay, our equivalent is 10 ohms, and the current flowing in the circuit is 2, or the overall current. Let's start now. This is 2 ampere current going from here, and 2 ampere has to reach everywhere. So this is having 2 ampere and 4 volts. This is having 2 ampere and 16 volts. Okay, so this portion is like 16 volts, and this is also having 16 volts. Okay, so if you calculate the current in this would be 1.6 ampere. I mean 16 divided by 10, and this will be 16 divided by 40. So this will be 0.4 ampere. This portion is solved, done. Now the next is like we have to get into the 3 volt. So this is parallel, so this is 4 volts, this is 4 volts. So the voltage, the current is 4 by 6 ampere. In this case, the current is 4 by 3 ampere. So this one is done. This is 4 volt, 4 by 3 ampere. Done. Now the next step. Uh, this is 4 by 6 ampere current flowing from here. So this will have 4 by 6 ampere multiplied by 2. So that would be 8 by 6 volts. And in this case, that would be 4 by 6 ampere, and multiplied by 4, that would be 16 by 6. Yeah, so it's done. It's done. The circuit is over. So I hope you got some basic idea to solve the circuits now. I think that's the last one here. Okay, so let's solve this quickly. This is 20 and 60, and the above circuit is 40 and 10. Then you have 20 and 60. So let's solve all of them now. 20 and 60 will be 20 multiplied by 60, 20 plus 60. That would be 1200 divided by 80. So I think this should give you an answer of 15. Yeah, we have 15 ohms over here, and this is 2 ohms, and 40 and 10 will give you an answer of 8. I think we solved that earlier. So this is 8, 15 and 2. 8, 15 and 2 with a battery of 25 volts. So the equivalent in this case is 25 ohms. All of them are in series, and the current will be 1 ampere because the battery is 25. So 1 ampere will be leaving from here and reaching all through the circuit. This one is easy, so let's solve this. This is 1 ampere and the voltage will be 2. Let's get to this one. The circuit, 1 ampere current will pass, and the voltage will be 15 volts on this. Okay, that is 15 volts. And then what you have for the next one, uh, okay, this is 8, so we simplify from here. This is 1 ampere and 8 volts is here. Okay, now let's get to the circuit. This will have 8 volts, and sorry, yeah, this will have 8 volts, and the current will be 8 divided by 40 amps, and this is having 8 volts. The current will be 8 divided by 10 ampere. Okay, now let's get to the circuit here. Back in the circuit, whatever we have done, this one, okay, the current passing from here will be 8 divided by 40 ampere. So we can calculate on this. The current is 8 by 40 ampere multiplied by 30. So that is, if you have to find the voltage, that will you multiply by 30, that is 8 3 is 24, and 240 divided by 40, that would be 6. Okay, and on this one, obviously the current is 8 by 40, and then you have the multiply of 10, that would be 2 volt here. Yeah, correct. Now the last one, we have the 10 as the final case. On this case, I think this was done. This is done. Only this one is left. So this is having 15 volts. Then 15 volts. This is also having 15 volts. So 15 divided by 60, that's the current over here. And 15 divided by 20, that's the current over here. That's done now. So this is the way you have to solve the circuits. And I must say that practice it once more, like on your own, and try to get over this, because such concepts are required in the basic solving of the circuits, whatever we are going to do in the next session. Thank you.